Hi, my name is Tariq Espinoza. I am a student at the University of California-Irvine, and this summer I work with Dr. Tariq Ahmido at the Engineering Research and Development Center at Fort Belvedere, and we were looking at the radiometric study of GmAPDs versus conventional InGaAs Imaging Sensors for fast tracking purposes. So our research was looking at the performance of shortwave infrared indium gallium arsenide, or InGaAs sensors that utilize one of two sensor types. One was the Geiger mode avalanche photodiode, and the other was the focal plane array sensor. Both cameras being integrated in there. The difference between the two camera sensors is that the Geiger mode avalanche photodiode, or GmAPD, allowed for single photon detection by reverse biasing the sensor near its avalanche breakdown point. And FPAs measure light intensity in a similar manner to what you would see in a charged coupled device, or CCD architecture. This study essentially aimed to investigate or evaluate the strengths of each camera sensor for fast tracking applications to inform future design in real-time detection. So the goal for the research was to integrate and control the cameras into this tracking system, perform radiometric calibrations and comparisons, and then assess the system's performance in varying ambient light conditions. So the methodology, as stated before, was we have both cameras, one at a time, being integrated onto the test bed. The system would incorporate into a synchronized tracking platform. So essentially what we would have is a target moving in two-dimensional space, and our camera would track and send a signal to our computer, which would then indicate to a laser that was visible to the naked eye to locate the target's position. So our radiometric calibration also included the bidirectional reflectance distribution function, BDRF, essentially a method of detecting the luminance of the target with different reflectances to simulate different surface scenarios. And the setup allowed for evaluation and tracking for both the performance and the response of either camera system. So our predicted finding, since the current research is still ongoing, is that the GmAPD based system is expected to perform better than the InGaAs camera sensor. It's expected to outperform in both low light settings and general detection. And the enhanced performance at any predicted wavelength is supposed to be used for better applications in the GmAPD. And also, the GmAPD is likely to offer more accurate 3D localization than the InGaAs sensor, along with better motion estimates. In predicted Army impact, this system, the GmAPD sensor, is expected to enhance Army surveillance, remote sensing, and high-speed tracking capabilities. It is also expected to perform or provide better real-time monitoring feedback for continuous oversights of unmanned systems, such as UAVs and UGVs, and also high-risk threats, such as hazardous moving materials coming from space. And lastly, for future applications, we can see the InGaAs camera sensor used as a support for precision power beaming for extended autonomous operations of UAVs, UGVs, and other unmanned vehicles.